Good day, ladies and gentlemen. We are continuing with first order differential equations for mathematics. So, as I explained in the previous video, for first order differential equations, these are the two key formulas that the mathematics students should know how to use them. They are on page number 7 of the formula sheet for mathematics. So, the first target is to rearrange your differential equation to look like this. Looking like this means you must get two terms on the left, where the first is dy dx, followed by some function of x multiplying y, then the rest you put them on the right. So looking at our differential equation, we can already see that we've got a challenge because we only have one term on the left. So we must make them two. The next term that will join that side must be the term that contains y. So looking at the right hand side, we see that x is the LCD. So LCD means x, this x belongs to everyone up there. So we'll divide everyone by x. So doing, I'll get dy over dx is equal to, I think, 2y over x minus 3x over x plus 1 over x. So it means in total I've got 3 terms on the left. But those 3 terms, one of them must move to the right to meet dy dx so that it looks like a standard form. So the one that is moving must be the one that contains y, which means therefore that this term has to move across. So if it moves, this means I'm left with dy over dx minus 2y on x. Since this is moving, is equal to, on the right, I can see that x here will take care of itself. So I'm left with negative 3 plus 1 on x. So up to so far, that's what I'm seeing. So I'm gradually getting close to what we call the standard form of a first order differential equation. The only thing left for me to handle is making sure the positive sign in the standard form is visible in my problem. So if it was a positive, then I'll be sure I'm done with things. In the place where there is supposed to be a positive, I'm seeing a negative. All you need to do is put your positive, create a bracket, then out of that bracket you put your y, since y is supposed to be part of this term. Then what goes in there is that negative sign together with the rest of this term. So I'll get negative 2 on x. So that is the way it is. Then on my right hand side, I get my negative 3 plus 1 over x. So up to so far, that is how far we've gone, and this means I've succeeded to see my p, and everything on the right is my q. So I've succeeded to readjust this problem to look like the standard form. So now that I've seen the standard form, the idea now will be to take p and q into the next equation and start solving, which is usually very difficult. So I usually split it into smaller bits so that we'll solve the little bit before we come and substitute into the formula. So I know my p. This therefore means that the integral of p dx will be the integral of negative 2 on x dx, which will simply give me negative 2 in x. So that means I'm done with that exponent. Then from that exponent I cut to the next bit. The next bit is what I'm putting in a rectangle, which also appears on both sides of the formula. So that is the next bit of my calculation, and what I've put in the rectangle is called the integrating factor. So my integrating factor IF is e to the power the integral of p dx. So my integral of p dx, I've just finished doing it. So it gives me negative 2 in x. And this is where we need our laws of exponent to help us out. As I've explained before in another video, when you get e to the power the ln of 5, expect it to give you 5 if you can put that in your calculator. Which in simple explanation we can say it simply looks like lin and e are cancelling one another. So, but what if there is a number on their way like this? You will no longer be able to cancel, so you will need to apply a law of log here to move the 2 to the exponent so that you get e to the power the lin of 5 to the power 2, which will give you 5 to the power 2 or 25, and you can now explain that as long as the law of log has removed that 2, then it allows e and lin to cancel. That's how we end up with 5 to the power 2, which is 25. So that is a simplification. You must know it from your laws of logs and exponent, which will now help us to get e to the power the lin of x to the power -2. And if e and lin cancel, I'm left now with x to the power -2, which is the same thing as 1 on x squared. So we have succeeded to get our if, the integration factor. So all we need to do is come now to this second formula, slot in the position of the rectangle on both sides. So if we slot that on both sides, we will get y multiplied by 1 on x squared on the left is equal to the integral of q, our q, you can still remember it, this is our q, which is -3 plus 1 on x, or this multiplied by 1 on x squared dx. So that is how far we've gone. So up to so far, what we can conclude is that the left hand side now is sorted. All we need now is to do the integral on the right hand side. So if I move it this side, it means on the left we get y on x squared is equal to, if I open the bracket on the right side, I'll get -3 on x squared. Excuse me. Because when I open this bracket, the 1 on x squared must go and multiply each of this. So the 3 is like 3 on 1. So while 1 is multiplying -3, x squared is multiplying 1. That's why we get -3 on x squared. Then the other one will be plus 1 on x cubed dx. So we can now move on with our integration. But with integration laws, your variable can only be at the denominator if the power is 1. Now that the power is different from 1, the variable needs to move up so that I'll get negative. I'll be having my -3 x to the power -2 plus x to the power -3. So that is what I'm having to integrate now. So if you integrate this, you'll get -3 x to the power -1 and -1, because we need to add 1 there, it becomes negative. Then plus x to the power -2, if you add 1 to -3 is -2, or -2 plus c. So up to so far, we've got our general solution 1 squared plus c. So all we need to do is to make sure we don't see all those negative exponents. So if we simplify that, we'll get our y on x squared is equal to 3 on x for the first term, because -3 on -1 will be positive. Then the x will go down, then -1 on 2x squared plus c. So as I was saying, if this question was looking for a general solution, then this is obviously where we'll be, because this, you always get a general solution when it involves plus c. But you can see very well that in our equation we are looking for the particular solution. That's why they gave us the values for x and y. So all you need to do is to take the values of x and y, substitute them to get the value of c. So if I take my y as a 3 and x as a 1 and substitute right through, this is exactly what I'm going to get, plus c. So I replace every x by 1 and every y by 3 as indicated in the problem. So that is telling me that, looking at this, it's simple to see that our c is positive a half, because this 3 will go that side to cancel the other 3. 3 minus 3 is 0. Then -1/2 will go that side as +1/2. and therefore I have my particular solution, which requires me to take the value of c into its position in the general solution. So my particular solution is y on x squared is equal to 3 over x minus 1 over 2x squared plus 1 over 2. So guys, that's how easy it is to get a particular solution for